We're now going to direct our attention to solving exponential equations. In this first exponential equation, we're going to recognize that the equation is quadratic in form. We have 4 to the x power minus 2 to the x power minus 12 equals 0. What we need to do here is recognize that the base 4 can be written with a base of 2. We can write 4 with a base of 2 by recognizing that 4 is 2 squared. That gives me 2 squared to the x power minus 2 to the x power minus 12 equals 0. Now, 2 to the x power squared can be written as, what I'm going to do is flip-flop these exponents. Right now it's 2 times x. There's no reason that I can't write it x times 2. In other words, I'm going to get 2 to the x all squared minus 2 to the x minus 12 equals 0. What I want you to do now is recognize that this expression is quadratic in form, with the base being, or the variable expression being 2 to the x power. It's something squared minus, if you will, 1 times that something minus 12 equals 0. In other words, if I let u equal 2 to the x power, watch what this expression becomes equal to. I get u squared minus u minus 12 equals 0. Well, u squared minus u minus 12 is certainly a quadratic expression, and we can factor it as u minus 4 times u plus 3, and that'll equal 0. By the zero product rule, that means that u equals 4 or u equals negative 3. But remember, in my original problem, I don't want to know u, I want to know x. So now I go ahead and back substitute. In other words, 2 to the x equals 4 or 2 to the x equals negative 3. Well, for 2 to the x equals 4, I can just say 2 to the x equals 2 squared, because 4 is 2 squared. And then, because the bases are equal, we can set the exponents equal, and we get x equals 2. In this expression, 2 to the x equals negative 3, that guy has no solution. And the reason it has no solution is because of the fact that 2 to the x is positive for all real values x. You should remember that because the range of the graph of y equals 2 to the x power was all positive real numbers. So again, whenever you have 2 to the x equals any kind of negative number, or really a to the x equals a negative number, you're going to have no solution. So our solution set to this problem is 2.
We've now seen how to solve an exponential equation that's quadratic in form using algebraic techniques. Now let's look at how we can solve that same equation using a graphing utility. Recall that we have 2 options when using our graphing utility. We can use the 0 option or the intersect option, both from our calc menu. Looking at our equation, we see that we have an expression equal to 0. So we're going to use the 0 option in this case. Go to our graphing calculator, press y equal to, and we're going to enter that left side of our equation in y1. So we'll have 4 to the x power minus 2 to the x power minus 12. We're going to graph that on our standard viewing window by pressing zoom 6. And we're going to look for where the graph crosses the x-axis. In this case, it looks like the graph is going to cross the x-axis at around 2. To find that value, we'll go to our calc menu by pressing second and trace. We're using our 0 option, so we'll use option number 2. First question we get is our left bound. We want to choose an x value that's clearly to the left of the point we're interested in. Since we think the 0 is at x equal to 2, we're going to use 1 as our left bound. For our right bound, we want to go clearly to the right. In this case, we'll use 3 for our right bound. For our guess, we want to pick a value that's between 1 and 3, that is between our left and right bound. We think the solution will be 2, So we use 2 for our guess. And it turns out that the 0 is x equal to 2. Let's drag this over. When we use the 0 option to solve equations, we're looking for the x-intercepts, or the zeros of our function. That is, the values for x that make the function equal to 0. In this particular case, x equal to 2 made our equation equal to 0. So the solution to our equation is x equal to 2.